material that we have so far covered as part of the course. So the Java in a nutshell, 6th edition, orally, chapter 1, Introduction to Java Environment, Introduction to Design, okay, working with Java collections, file handling, and there is actually a need to add the threads part, no, the network program. Chapter 6 it is there. Okay, yeah, okay, these are the things that the initial part of it is covered in these chapters. Okay, the second part of writing the Hadoop distributed file system is from Hadoop, the definitive 4th edition O'Reilly media. Okay, the slides that I have used, then this is actually the on part. The cluster setup, you can see this, but this is not required. I think we have already given this. You can watch the corresponding thing. This can be removed. The Vishwa setup is already given as part of the this thing. Okay, this is the material that was covered. We'll mail you the PPT slides to individual students who have actually given their email address to us, and all the lectures have been recorded by the, more or less all the lectures have been recorded by the AView software, and I could see them as part of the AView system. Okay, so students who have access to the AView system can see all the lectures that were given as part of the course, and that's also constitute the study material for this course. Okay. Is that clear? Additional reference material I will give you on Saturday, but then we will also provide you with the PPTs, certain PPTs which we have. Okay, you type the textbook name and edition. The textbook name and edition has already been given here. What additional material are you looking for? Are you able to see the desktop? Are you able to see the desktop? Yes, sir. Then it is there already in the desktop. Where is that one? Fine. Sixth edition, Java in a nutshell. Okay. We can use any other book on Java also, as long as it covers the concepts that we have taught. How to write the client server programs, how to write the Java threads, how to do the memory and concurrency approach to Java. Okay, all other things are part of the the rest of the concepts are already there as part of the Java, including we actually showed you how thread collections can be created, and you can use a pool of threads as part of the this thing. So if questions have to be set, we would expect people to understand how the client server programs are written, how the network, this includes the network programming, Java sockets are there. Okay. I think chapter 6 is the core, I thought. Is the book there? Is it somewhere? Can you bring up the book somewhere? No. How did you give this? I have the book somewhere, so we can exactly, can you just check if that Java nutshell is there in my this thing there? Okay. Right. Right now, I think whatever we've indicated there, that's the material. Okay. If there is any slight changes in the this thing, I think the textbook name edition is also available there. Okay, and the Hadoop reference guide is also given for you there. Again, it's a very specific reference. Okay, right? You can use any other book as long as it covers the same material. We have no specific material, but you can use this material for the course. Okay. Additionally, whatever I've covered, those slides will be made available to the students. Whatever little slide material that I have got, I actually can share that. Most of it we have shown you online, live, how to write those programs, how to make them work, and included the concepts as part of the course material. If there are questions that have to be asked, please understand our way of testing is completely different from the way the testing happens there. So I am actually only suggesting. What we will certainly give you is programs, small programs, and ask you to modify those programs as part of the course. We will ask design questions. We will ask conceptual questions. If you are doing with sockets in Java, how they are different, what are the conceptual understanding of the concepts in Java, because that's the basis for you to be developing any distributed program, including Hadoop programs. Okay, though you won't write sockets, in some sense, unless you understand the sockets, you will not be able to understand how the MapReduce programs are running in a distributed fashion. Okay, so what are ports, and why these ports are important for understanding how distributed programs work? So those are the concepts that we had covered. So the questions will be essentially should be based on those concepts. Okay, some part of it can be objective, some part of it can be true false, some part of it can be looking at programs and modifying those programs. We certainly don't want the colleges to give subjective questions where explain how Hadoop works. Things like that questions should be discouraged, and such questions should not be asked, and the questions should be very, it should have a clear conceptual base and should be able to make sure the student understood the concept, what he needs to understand. Okay, that's how the question paper should be set. Okay, these are guidelines that we are giving for the colleges. It is for the colleges to follow, and it is for the colleges to come up. We are here to only help them. Okay, it is for them to now look at what inputs we are giving and take those inputs and make sure that things are come up to that part. Okay, there's absolutely useless to set questions and give lot of marks to the students even when they have not understood even a single concept and not able to write even a single program on the machine and execute them. Such learning is, in our opinion, not useful at all. Okay, and it is not learning at all. It is meant for marks, and those marks have no meaning in my opinion. Please understand, we are here for a purpose, and the way things may be happening there, we have no control on it. But since you requested us, we are on a purpose here, and we are trying to do the way we feel comfortable about doing it. Okay, the number of times I am seeing people are asking material, the people are asking what kind of questions. They're more worried about marks, and they're more worried about the exam part, and learning is less of interest for them. That's what is the impression that we are getting. Okay, and that's that will discourage us from continuing with this, because we feel learning is important. Marks are a side effect of good learning, and if people are not focusing on learning and they're interested in marks, that's a different problem altogether. Okay, in which case this course should be taken more as an add-on course, not as a regular course of the university trying to get marks. Okay, this is meant for learning as far as we are concerned. Right, I think that clarifies whatever I think I need to clarify as part of the course. Okay, please understand, we are not involved in any of the examination part of the JNTU Kakinada, and it is up to them. Okay, we are only helping them give this course, and when we got into it, our mandate is very clear. We are interested in teaching the concepts and make sure people understand them, program them, and learn. That is how we have actually designed this course, and we are extremely clear about it, and we are not going to step into the exam part of the university, and it is for them to look at it, and then for you to actually work with them as part of this course. Okay, is that clear? Please don't ask this question. We won't answer any more questions on both the exam and also on the study material. Okay, right? Is that clear now? So let us get back to, there are only 2 classes now, and this is what we will do as part of the class, and that's where this class will end as far as we are concerned. Okay, we will explain the map reduce. We want the students, first thing is whatever we are doing it, we don't mind spending extra hours. Today if you are willing to sit, we are willing to sit for another 4 or 5 hours making things clear for you. Okay, we have no problem with that. Okay, but then it should be clear for us, this is why we are doing it. If it required for you to understand the map and reduce functions, want to understand, please tell me what you have understood by the map and reducer functions, and what do you, when you say explain mapper and reducer functions, which part of it is not very clear for you, and what extra thing are you looking at. Okay, can you just bring up the, I'll first give the full explanation by how the whole thing will work, right, and based on that we will go further. Okay, can you just bring up the code for me? I think this should not just become, even when this initially this was planned, we tell the university that this requires a lot more planning, but they wanted to start off this thing very soon, and that's how this got started. Okay, but then we are seeing that there are things where we were not, the planning has to be a lot more in terms of having such courses. And if the government is only interested in pushing things as fast as possible without doing adequate planning, we are not part of it. We are very clear about it. Okay. Yeah. So basically, here is an example of the. This is not meant for getting brownie points saying that we have run a MOOCs course and things like that. It should also help the students and should help them correctly and properly. When even MOOCs definition is not known and people want to run, because government picks up a word MOOCs from somewhere and wants to run this is not going to help anybody. Okay, people should do their homework properly when these things are done, especially the government. Okay, yeah. So the public here is the word count example. When you see this public class word count, so you're seeing that here. This is basically a class. So you basically what we are doing, as I've explained previously, is there is going to be a map function. Here is the map function. Okay, and then the map function is going to run on the different of it. So basically you have two parts that you are writing here. One is the reduce part. Everything is put into the same file here, right? Okay, so this whole thing is one file now. You're not splitting the files. Okay, one could have split this into different files as well. So basically, you have map function here in the word count. As you can see, there are two parts in the word count. One is the map function, and the other is basically the reduce function. So right. And then as part of the main function, main program here, you will create the job and fire this both map functions as well as the reduce functions. Okay. So let us understand how this whole program is going to work. Most of it is templates. So what you are trying to do is just take a word count file. This is the public word count file. Okay. These are actually the template classes. For example, here you can see the public class tokenized mapper extends the mapper class. This is a template class, and you can see here these are the types that it is actually taking. So every map function will take a key value pair and output a key value pair here. Okay. So the key value pair is, there is an object ID and there is a corresponding text. This is basically the corresponding string that you are going to get, and then it is going to output X, which is the keyword that it found in the text, and also a integer. So this is basically the integer, how many times that is actually occurred in that is returned as part of that. So every mapper takes a key value pair and outputs a key value pair. Okay. Now you can give any kind of types here. So this is, since it's a template class, you can give whatever types you are trying to use as part of this, and you can actually have you explained this to them? This was explained. Okay. So now this is where you're going to extend a mapper template class and then write your own mapper function. This is how the mapper function will be written here. Okay. The rest of the thing is just as you can see here, you're right here, the map function, the one which takes the within this mapper class, you are going to write the map function. This is the function that will take and then we'll try to actually write, for example, the output of this mapper function is written into this context. Okay, an object called the context here. Okay, now as you can see here, it takes each of the word and actually putting that word and the count as 1. This is the output of this. We are taking the context object and writing the value, okay, of the key and the value into this, and this is how you will produce. Okay, this is how you will produce the mapper output. You are iterating as more tokens. Every time you have the next token, writing the word, and then while iterating on this, you are actually writing the output, that word and 1. This is the output that will be part of the mapper function, the text and int writable. So what this function will produce now, this mapper function will take a text value, take all the this can be a long string, and then it processes this string, takes every time it has a new token. Okay, it takes this text is the value to string tokenizer. These are actually the predefined functions that you are using, right? And then you are iterating. It has more tokens. You are actually outputting each of the new token as a word and then 1. Now, if you take, for example, all the colleges are doing this Moocs course. This is a line. Then colleges, all the colleges, okay, all will be keyword. All 1 will be output here. So each time this value is given, you will create the string tokenizer here. Okay, ITR will become the string tokenizer, and you will iterate over this as more things. Every time you are actually getting the next token, the word is set. You actually now that word becomes the object. You're writing into this context, which is the output object, that word and 1. For example, here all will be the word, and 1 will be the how many times it actually occurred, right? Then colleges, again college 1, okay. Then Moocs 1, like that. Every token that is available here, every token that is found in the text value will be output by this as an output value. That means this mapper is going to this mapper function, this class is going to take each of this text value, reads each of the text input, converts that, finds all the key values, outputs values into this. Okay. Now you can see the reducer here. The int sum, the next is the reducer class. What the reducer does is int sum reducer. This extends the reducer text int writable. Okay, text int writable, which actually means that it takes each of these text values. Okay, whatever key that you have got and all the values that you have got as part of the key here. Okay, this is the set of values that you have got, integer values that you have got here. Then it will finally output. For example, it will sum up all the values here. Int sum, for int writable values, you are actually now iterating over this, adding all the values, and finally you are outputting key and its result. This is the context that you are actually outputting. This is the final output value. Key and its value is what this reducer will output. Okay. Now you have written the map function, you have written the reducer function, then you write the main function. Okay, the main function you create now the configuration. This is the new job configuration. Okay, and then you set whatever is required. Here you are giving the word count. Okay, the name. Then you are actually putting the job. Okay, set jar by class. This will be the word count class. Then you are giving the mapper class, and you are giving the combiner class, and you are giving the reducer class, and you are giving the output key class. Okay, what is the final output key class? What is the what will be written as a final output from this? Okay, output. Okay, and then you are actually giving the file paths from where they should read the input for this particular thing. Okay, all the input files are set here, and you are giving the output path for the job where it can get. This can also be given in the these are all the configuration settings that you are making for your program to run. Okay, once you have set this, now you can actually run this program. How did you run this program? Where was the do you set up the, have you opened the cluster is open? Can you just give me the cluster? There are three. See, okay. So let us go through this part. Where are the masters? This is the master. Okay. Okay. That's what. This is one node. This is a master. Can you get all the three nodes here? No. Okay. Slave 2. Okay. So there are two data nodes. Why are you telling master and slave? You could also use them as a name node and the two data nodes. These are the two data nodes, right? Yes. Okay. So we have two data nodes and then one name node. Okay. That's what the configuration they have. Any questions up to this point? What is the time we are doing? 3:05. Okay, I don't know how much time we have. Okay, so let us you compile the RAM, and have you created the jar file for this? Okay, what jar is it? Okay, and then the okay, let me explain before you actually running it. Okay. Yeah, so what you have is you're actually having the Hadoop file system, okay, and then what you are doing is you are giving the now in the case of running this, have you run this previously, or this is the first one? So you're giving the jar file and the input this thing, right? Share. It isn't share. Just write full this thing. I think I should have done it myself. Or you using the example jar itself, is it? And this is extracted from the example jar. You have not written it yourself. Okay. Ideally speaking, I have my own files for this, right? I give the input here. Input is what? This is just slash input. Hadoop HDFS input. Okay, check that and then tell me if where is the input. Otherwise, without the input, how will you run this? Where did you put the input? I can go to Amazon ECR and run the cluster directly there. There is a problem in setting up it here. Have you run this last time for them? So how did you show? Given the input, but you don't remember which code it is. Okay. Huh? See, the way it will work now is, let me give this before they find the path for that. They seems to have not got the path here. So the way it's going to work is the following. Now, this is where the Hadoop is, and then this will, there are some questions on how the task tracker and the job tracker are going to work, right? This is basically the job. This is where the job is getting submitted. This word count where you have written the map files and the reduce files has been submitted. Okay, so this becomes the tracker now, which means that you submit this job to a job tracker. Okay, now this job tracker is running on one of the nodes of the cluster. Okay, now the job of a job tracker is to find out where the file input file blocks are located. Okay, based on that it will try to create, okay, it will find out the nodes on which the map and reduce jobs can be run. Okay, that's where basically the task tracker, every node will be running a task tracker. The task tracker will be communicating with the job tracker. This is by a heartbeat algorithm. Okay. Now, using this, the job tracker can find out enough number of tasks in task trackers nodes on which a map job or a reduced job can be started. Okay. Now this will, what initial version of the Java has, Hadoop has, that's a Hadoop 1, has is, you have to have separate slots. Okay, each task tracker can run, okay, either a map job or a reduced job. That's basically called the slots. Now, what you do is the job tracker automatically will find enough task trackers, that means nodes that can run your map reduced job, and start off the map. Are you able to find? Okay, find the, this is the this is the input file. Is the bin not there? Yeah. Yeah, now you can see by looking at this, you will be able to know what is all happening. Okay, for example, submitting tokens for the job. As you can see, number of splits is 4. Total number of paths to process is 4. That means there are actually 4 splits that have been done. So we'll just go back to this. Can I just roll back? Now you look at what really is the starting point for this. Okay. Now as you can see, this node is where you have submitted your job. Okay. Now input file format, total inputs to paths to process is 4, number of splits is 4, map reduce job submitter. This is actually the one submitting. These tokens are required for recognizing. We will not get into this right now, how the security part is ensured in this. So you need a token for for the jobs to be running. You can go a little deeper on the architecture of the MapReduce jobs. Now, as you can see here, this is the slot that is running your job. This is basically the job tracker. Okay. Now, this is what finds out enough number of maps, and this is a very small this thing. I think it didn't take too much time. Okay. In fact, if you run it for a little longer, it will show when the reducer got started. Here, I think there's only one reducer here. Okay. What you have here is once the required number of maps are started. Okay, the required number of, for example, here there are 4 splits. So actually 4 maps would have been created for running on the different nodes. Okay, and what the task job tracker will do is give the jobs, split jobs to these task trackers, and the task trackers will be running the map jobs or the reduced jobs. Now, one of the key things is when you start a map job, here you can see how the how much percentage of the map jobs and the reduced jobs actually got started, and how the whole jobs are progressing. Okay. Now you can see this from a different point. Where is the program? The program is word count program. Okay. Let us go back to the program. As you can see here, when you actually start this and enough task trackers have been found, now each one of them will be running this map class here. This is what will be extracted out of this program. This is the map class. Okay. Now this map class gets loaded when a map slot is running. That means it will essentially run this part of the program. This class will be loaded as part of the task that is running the map job. If it is running a reduced job, then it will be running this following class, which is the reduced class. Okay. So a slot is available on a node. A node can pre-declare a client node. That means whatever is the data nodes or the nodes that are there on the cluster can declare how many slots they're willing to give for the cluster. Now, the job tracker can locate required number of slots. For example, I have 20 slots for running my map jobs. Okay. Earlier, the map slots in Hadoop 1, the map slots are different from the reduced slots. Okay. Either you can run a map job or you can run a reduced job. In actually Hadoop 2, they've changed this architecture where you can run either a map job or a reduced job. Okay. Which means that, let us say in the cluster I have 20 slots. To start with, I can allocate all the 20 slots to the map jobs. As the map starts running, produces the output, then I can start the reduced slots. So slowly I can see the reducer is going to start a little later, not initially. So what I do, now I will actually put a slow reducer start. When I have finished up to 80%, then I start my reducers. So reduced slots will be allocated after 80% of the maps have finished. After that, reducers may have more number of slots, running more number of reducer could be running on more number of slots. Okay. So it's possible to run map slot or reduced slot in Hadoop 2. This is basically a slot, which is called a container. It can run a map job or it can run a reduced job. So essentially, the whole framework of Java helps in doing this mainly because, as you can see, the classes can be read over the network. Classes here. One is the map class and the other is a reduced class. Okay. Now you can extract this class. The slot there will load the map class and will run this map job in the slot. Similarly, with the reduced slot, it will load this class and run the reduced slot. Okay. Now this whole setup at the end, whatever you're doing here, you are just specifying all the parameters for this, which are the map class, which are the reduced class. These are all being given here. Okay. And this will be used by the system to actually load these classes. So whatever they are giving here as a system configuration, okay, when you are starting your job, the configuration, they are actually creating a job now, a new job here, and you are setting all the parameters of this job object, okay, which includes what is the map class, what is the reduced class, and what is the jar where these classes are available, so that the whole thing can be taken and can be loaded in a distributed fashion. The beauty of this whole framework is you will not write any socket programs in this program. We started off with socket programs. If you look at it, for writing our client server programs, we have written the Java sockets and written the programs in the Java sockets. Okay. Whereas here, is this not moving? Here, there is not even a single socket. You can see all that the program has been written here is a mapper class and a reducer class. Okay. And then you are setting the job parameters that are required and firing this job. All the things are being done by the Hadoop framework. You are absolutely not writing any distributed program. You are abstracting this to say, I will just write a map program and a reduce program, and rest of the work is done for you by the Hadoop framework. The Hadoop framework does hell lot of work using their sockets and all that for you. It automatically doing a lot of work of locating the nodes, running your job in a transparent way for you, and getting the output back to you. Okay. So the catch in this is the program, the distributed program you are running has to fall into this pattern of being able to write a map class and being able to write a reduce class. Okay. So this is the limitation. For example, the only programs that can be run by this framework is those that can be written as map jobs and reduce jobs. Then only you will be able to use this framework. Otherwise, you won't be able to use this framework. What is the other very interesting thing? Once you've written this program, you can set up a 10 node cluster, 20 node cluster, 100 node cluster, 1000 node cluster. This program is not going to change. Okay, this program will remain the same. The only thing is you will set up the cluster, and once you run the program, it can run either on 3 nodes or 100 nodes exactly in the same possible way, right? So that's the beauty of writing your programs in the Hadoop framework, which becomes extremely simple. As long as you are able to write a map and a reduce program, you are avoiding writing a lot of distributed, the way we wrote traditionally the distributed programs using the socket programming is all gone. Okay. I think, are there any questions at this stage? I might want to go a little deeper. Okay. Whether map reduce is Turing complete. Okay. Right. This is a completely different question. Right. So basically, we will get into a different discussion if we want to get into whether MapReduce is a good. That's an excellent question, in fact. Okay, yeah. Desktop is not. Okay. Any other questions? We'll come back to Turing complete. If you want to actually argue whether MapReduce is Turing complete or not, whether MapReduce is a complete whether you can express all computations, okay, using MapReduce, the obvious answer is no, right? So we can go a little deeper and analyze what MapReduce really means. Okay, MapReduce really means. Okay, what kind of computations one can really express. Yes, see. We actually didn't discuss the combiner class here. Okay, what the combiner is supposed to do for you. There are a lot of caveats here. If you want to understand this, for example, if in a partition in one node, when you are looking for one keyword, let us say the keyword in that there is a say Kakinada, Jntuk Kakinada. This is a keyword. Okay, this keyword in one partition has occurred 20 times or 30 times. Now, one way to actually produce this output is Jntuk Kakinada 1, Jntuk Kakinada 1 20 times. Okay, and then send all this output to the reducer, and the reducer will combine all of this output. Not only this partition, but across all the other partitions, and we'll say Jntuk Kakinada 40 times or 100 times, whatever number of times that it is appeared. Okay. Now, instead of that, what combiner will do is the local output of the maps will all be combined. That's what the combiner does. Okay. It combines and produces the key and a value pair, which is a combiner of the local output of the maps. Okay. And that is what is actually pushed to the reducer side. Okay, that's what is sent to the reducer side. Okay. Okay. In fact, coming back to the question. Okay. So you basically don't want n number of 20 times the IIT Madras, appearing. For example, the keyword is IIT Madras 20 times, 1111 IIT Madras, 100 IIT Madras, 1 like 20 times. Going to the reducer side, now what you will do is IIT Madras 20, you will reduce, combine it to 20 and then send it to the reducer side. Okay. One of the key problem with MapReduce, when the Turing complete question is asked, the important thing that you should understand is MapReduce has limitations. So certain computations, including the iterative computations, cannot be expressed very easily in the MapReduce framework. Okay. For example, we gave the assignment on the co-occurring words. What is the way you're going to express the co-occurring words? In MapReduce, since there is only a map and a reduce function, okay, iteration cannot be given as part of the MapReduce computation. All that you can give is a map function and a reduce function. So suddenly, can I now a computation that requires iteration? That means I'll find out first all the words that have a frequency above some value. Then I want to actually go to the next iteration of finding out whether two words are occurring at that same frequency again. Then I have to now do all the combinations. For doing that, the only way, that's the reason why that question is asked. The only way you can do that thing is first take one iteration, find out all the keywords that are above, occurring 50 times above, then see the combinations of that. That's what you're going to now, next iteration you are going to find out. Again you will run another MapReduce job trying to find out how many times these pairs of keywords have actually occurred, and that's how we are going to sort of run multiple times the MapReduce station there. Okay, each time you fire the MapReduce job, find the output, and again try to run it one more time. Okay, so that becomes very complex thing. So you can't express all kinds of computations. You can't do that. Okay, can we put a loop in the main? You can't. That's obviously the problem. Okay, the main you are only giving here. Please understand, there's a framework there. All the framework does is given a large input, given a mapper function and a reducer function. It's actually very complicated middleware. Okay, it runs this mapper anywhere. All the outputs that are coming from the mapper are shuffled, sorted, and given to the reducer. Okay, right? So the middleware does a lot of work for you, gives the output of these mappers to the reducer. Reducer does some work and finally produces the output for you. You can't put any loop in this. All that you need right now is a mapper function, reducer function. You can't give an output of a reducer to a mapper again. You can't. You have to start it as a separate MapReduce job. Okay, that's the only way you can do in a normal Hadoop MapReduce framework. So what you need to do, and please also understand, the mapper output is not stored in the HDFS. The mapper output is stored in the main memory. So what the middleware does, as these keys are I think that question is not correct. MapReduce will take advantage. See, you are giving now proposals, right? All of you are giving different proposals. Okay, these are no longer part of the MapReduce framework. For example, somebody is asking whether this will run on GPU. GPU is completely different ball game, right? The architecture, GPU architecture is completely different. So we will not get into that because GPU is for fine latency computations. For example, we are doing a large matrix addition, multiplication like that, and on a single value you want to get faster. There is actually the small cores there, and then you can do certain computations extremely fast in GPU. Okay, but then map and reduce, as you can see, there are coarse grained functions, and these functions are written in a higher level language. and you are extracting them as a class, and you are running them on a loosely coupled distributed systems. You can also try, there are people who have done this, but then let us not get into that thing now. That's basically, GPU is a completely different architecture. There is no latency issue here because the map produces its output into the memory. I think there are a lot of conceptual gaps in the questions that I'm getting now. Okay, as the output is coming in, it is written into the main memory. It's also possible there is a spillover that will be written onto the disk. Okay, please listen to me a little carefully. And the next question that is coming in is, can we write map 1 reduce 1 then map 2 reduce 2? There is no way you can connect them together. There are other proposals like iterative map reduce and other things like Spark, which allows you to do a workflow. There is UZI kind of thing which will allow you to specify map reduce workflows. That is a layer above the map reduce, which means that you will be able to specify the workflows. Okay, and that's what people do. They specify the map reduce jobs as workflows, and then the map output is never written onto the hard disk. The map output is written onto the main memory. It is not written, that's not correct. It is not written to the HDFS. The map output is written onto the main memory. But once the main memory, you fill up, then it spills over, the records will spill over into the disk. Now what the shuffle and the sort will do is, what the shuffle and sort will do is, it takes the key. First you understand the word count example. If time permits, we'll show you how other examples like you can do the k-means clustering. Okay, is this on or it's off? Yeah, so first understand this. The other examples of writing this, for example, we have given you the Twitter example, okay, the hashtag example. We'll also, if time permits, we'll show you how to do a large weather files, data files. You can process them using Hadoop kind of thing, okay. For example, you have large weather data stations, weather data stations, each station and what is the temperature, over a period of time. If those files are available, how we will process them using the Hadoop framework. All these other examples we can do if time permits. Okay, we can show you how those examples can be written, but all of them follow the same process. What is it that you want to do on each record? That will become a map function. Okay, once you get the output of that, you have to write a reducer to get all these outputs together and present the final result that each individual task has done. So in some sense, what you do is, given a data, you split the data, and on each data, what needs to be done is specified as a map function. Okay, and then that is the output of each map function is given to the reducer, and the reducer will combine all the outputs of all these maps and will finally produce the output value. So any kind of example that you want to write on map reduce, you need to understand how to split the data. Once this data is split, any large data, you split that data, then specify the map function. Okay, and how these map functions work on this data, and whatever output is coming from these map functions, how we will feed that into the reducer. So that is the connection of writing a map reduce job. So what is the word count example teaching you? In a simple sense, what the word count example is teaching you is, each map will take as an input and a key and a string, okay, and then it counts the keywords and produces its output as a keyword and a string and a value. Okay, now the reducer takes all these different outputs. So the reducer will get an output of a keyword and the list of values. It adds all these values together and produces the final output. This is what the map reduce framework is all about. Now, how do you write different other examples given something? For example, there is weather data. On a particular day, what is the temperature that is given? What is the different, every hour, what is the temperature that is recorded? Let us say the map produces for every day what is the maximum temperature that is produced. Map can now look at that record and tell what is the day's maximum temperature. So it can read in a particular year all the maximum temperature, and then it can give all the maximum temperatures of that particular month or year. Okay. Now this maximum can be fed to the reducer. Reducer looks at all the maximum coming in and finally produces one final maximum value among all the maximum values it is looking at. So when you want to see with a large weather data file, you want to find what is the maximum temperature recorded in a year, you can write that as a MapReduce program. And this records could be huge number of millions of records. Now you can split them. Every mapper will look at what is the maximum it is looking at, and it will output that maximum. And as a final reducer takes all the maximum, and final maximum can be output as a maximum value that is recorded in a particular year. That's how you will write a MapReduce program. Okay, this is not a word count example. This is a completely different example. So any example you want to write a MapReduce program, this is what you will do. You will write a mapper, you will write a reducer. The mapper will work on the split data, produces an output which will be given to the reducer. The reducer should be able to now collate all the outputs of the individual mappers, give you a final value. If you are able to write this, split this, write this as a mapper and a reducer, then you can exploit the MapReduce framework and then can run on a large data set different other things. Now the biggest advantage of using the MapReduce framework is when you have this framework, you won't write the low level network calls, okay, Java socket calls. Okay, I will ask you, for example, if you want to just do the same word count example, please write a corresponding Java socket program on 3 nodes, then you will know how difficult it is. Okay, and why people don't write that and why people will prefer the MapReduce framework for doing this. Okay. Now you can do aggregation. For example, on the weather data, I want to find an average. I can write this. Okay. Certain other tasks are impossible to be done using the MapReduce framework. Okay. For example, the computations that don't have certain properties cannot be expressed as a MapReduce computation. Okay. For example, every time you based on one computation. Okay, how much time are we having now? See, are there any other questions before I go further? Sir, how to write iterative algorithm? This question is coming again and again. I am telling you, MapReduce, you can't put iteration. You have to write outside MapReduce framework. Run it, again fire another MapReduce job again. That's how you will write an iteration. An iteration is outside of the MapReduce. You write a map and reduce, finished one iteration of the MapReduce, again start the MapReduce. The output of the reduce is written onto the HDFS. So for starting an iteration, you have to go back and start the reducer, MapReduce computation again and again. That's what Mahout, the libraries such as Mahout will provide you the ways of writing the iterative computations on top of MapReduce. So there are libraries available, okay, which you can use for writing the MapReduce computation. Doing the research on this for the last 7-8 years. Okay, the bigger research of ours is to actually extend the MapReduce framework. We call that as Generate MapReduce framework, using which not only iteration, lots of other things you can do as part of that framework. And that framework was implemented at IIT Madras. Abhinay will actually share that paper with you. Okay. If you look at Generate MapReduce, we show that that is much more powerful in terms of expressing more general computations than simple MapReduce. In fact, we show using generate MapReduce on clusters, you can run k-means clustering kind of jobs 50 to 60 times faster than actually doing it using MapReduce. Okay, that's one reason when we worked this research with Yahoo Group, Yahoo Research Labs, they actually set up this Yahoo Grid Lab in IIT Madras as part of that research. Okay, so we have it that was set up, donated by Yahoo Research for for this purpose. And one of the things that we experiment on that cluster is how we improve the MapReduce job performances. Okay, how efficiently MapReduce can be executed on clusters. Okay, that is a major research team as part of our group, including Balaji is right now looking at how to improve actually the MapReduce performance on heterogeneous clusters, and that's where we use this Boss-Mool operating system for improving the we collect the data of the individual nodes, how they're performing, and based on that we do the data split, and wants to exploit that for showing a better performance of MapReduce job execution on clusters. Okay, all the work that we have done in this space, Abhinay will share, including the how the map, if a map job is skewed in terms of execution, how that can be improved. If the reducer has more workload, how that can be improved. A lot of work which we have done in that space. Okay, for completeness sake, he will share some of this work with you. Okay, you can look at it. If you have doubts, you are certainly welcome and ask us. That's something that people have been looking at. But this course is largely at this point of time to understand how MapReduce will work. Okay, are there further questions on what I've covered so far? How much time do I have today? Okay, I'm not going to take the class on Friday. Are you okay with taking the class on Saturday between 10 and 1? First, let me go in a systematic way. Are there any questions now so far on what we have covered so far? Do you now understand? We can go a little deeper, and we'll further can show you how map runs in waves, and then how the output of that will be actually given to the reducer, and then all further details can be gotten into. Okay, that can be done as part of the execution sequence, which I'll show you. I'll also show you, if possible, how you can fire a MapReduce job on the elastic MapReduce cluster from Amazon. How you can start up. I have this other cluster here. This other cluster running. I think there are 3 nodes which I wanted set up there. So, but where are these? Are virtual machines which are running here, right? These are installed. So they are actually not on the virtual box, they are on the actual machine. Okay. Right. So these 3 nodes that I'm seeing now are the nodes that are running the Boss-Mool. Okay. Yeah, okay. So next time I'll show you, if time permits, I'll show you how to start this MapReduce jobs on the elastic MapReduce cluster on the Amazon. Okay. Is that clear now? And there I will show you the logs also. Whatever logs will be written by the running jobs, and then has anybody got is following this thing, starting the name node in a safe mode? Has anybody got this message when you're starting the name node? Did it ever say starting in a safe mode? Has anybody there got this message? Can anybody tell me what does that mean if you've got this message? Starting the name node in a safe mode. Has anybody got this message? Nobody got this message? Safe mode? That's surprising. I think the first thing it will do for you is put safe mode. And you have to switch off the safe mode. Okay? What does the safe mode mean? The HDFS. Has it got anything to do with the replication factor? How does the required number of replication factor achieved by the name node? What is HDFS replication factor? Have you got some students now? I want to actually spend some time today. I have time till I'm already reaching 4. Which campus can publish now? Aditya campus was telling that they can publish their video. Can they publish their video for me please now? Is it possible for you? They said after 15-20 minutes they'll publish their video for me. Which other college is ready for publishing their video? I want to directly interact with the students. Which other college is ready now for publishing their video? I want to interact directly with the students. Is there any college willing to publish their video now? Student video? Who are these people who are asking me these questions? I'll be, no. Both are publishing, okay? So let me go to Gudlavalleri College. Okay. Say selected college is not publishing the video. Only Vijayanagaram College is the only college which is publishing its video. No, it's still not coming for me. Audio video stopped. Still not seeing the. No. Which college is willing to publish its video for me? I just want to interact with the students. See, we're willing to spend and then make the colleges learn, but then we also want to understand who are the students and what they've learned so far, and then what questions they have, okay, right? And who are this? Can I just get, for example, the person who has asked me the question, okay? Some more examples on the for MapReduce. Who has asked this question? How to write other programs other than word count in the MapReduce? Who is the person? Can he come online with me? I want to interact with him. That's a nice question. Is that possible? Is that possible? It's a nice question. I want to see the student. I want to interact with him. Okay. I want to tell him, how exactly. For example, how many of the students have worked with the Lisp? Has any student programmed here in Lisp? Yeah, I'm getting Gudlavalleri College now. But lights are not off. I'm not seeing anything there. Is somebody there? Hello, is somebody there?
Yes, sir.
Yeah, I'm not seeing. Yeah, I think can you increase the? Yeah. See, have you programmed in Lisp? Has any student there programmed in Lisp? Okay. Do you see there is a correlation between Lisp and MapReduce, or there is no correlation? Programming in Lisp and MapReduce. or any functional programming. What is the difference between a functional programming language? Who asked me the Turing complete question? See, can you think and tell me where you will find it difficult to write a MapReduce program? Can you give me one example where it will be difficult to write that program as a MapReduce program? Can somebody there answer me this question? I'm seeing nice boys there. See, this is what gives us a kick, right? Something that I'm missing all along is this physical interaction with the students, right? Here I'm teaching, but then I still need this interaction. Then only I feel satisfied. Yes, it's going to the people, they're listening to me and understanding, right? My biggest concern is Jntuk Kakinada is probably should be rated lowest. But most of the time their students are not present at all. I can't understand this. They are in swimming classes, there are other classes when this class is going on. I can't understand this at all. For whom am I actually spending this time and teaching? Most of the time, if they have other schedules, why are they wasting my time? Okay, that's a different question. I want to put this because they should take this seriously. Most of the time, I've never found that college at all. It's my own college. They should come now. They should be, using this interaction part, and then should come back. I can't understand that. Yeah. Anyway, that's no. Sometimes as academicians we have to tell this, right? Okay. So can you tell me? This nice that I'm seeing this college. Nice boys, nice. This thing. So is it possible for you to tell me where it will be difficult to write a MapReduce program? One example. Can you think of a map and reduce will be very difficult? Give me an example for that. Any other college willing to give me an answer for this question? See, the biggest thing here is there's a combiner, right? Or reducer is just taking the output and just combining. And there is a property that you're seeing there. If this property is not, there's a particular property that is required for you to be able to combine all the outputs of the maps into the reducer and give the final output. If that is not possible, that's not easy to do for you, it will be difficult, right? So can you think of, I will share my email address. I would like to see if anybody can send an answer for this. Okay, please send this to this address. Okay, what kind of problems will be difficult to code in the MapReduce? Okay, what is this Jntuk 50? What is it that they're telling me? What is this? Pakat? What is the thing that Jntuk 50 is putting it in the chat? Is that a question or is that? Which is Jntuk 50? Can you identify yourself, please? Jntuk 50. Which college is this? What is the college name? I'm seeing this as only Jntuk 50. Which college is this? A large volume book like Bhagavad Gita. So what is the, okay. What will be the problem? PVP SIT. Okay, what will be the problem with a large volume? It's actually good if there's a large volume book and you want to find out how many times Krishna occurred in it. It's a good example for MapReduce, right? So what is it that you actually, so are you saying it will be difficult to do that for Bhagavad Gita? if I want to find out how many times, no, but then that's not correct. Okay, who is actually, can Jntuk 50 publish its video, please? Lot of volumes is fine. So what is the problem with lot of volumes? Basically, that's good. The more data you have, that will be good, right? Jntuk 50, I would like to come to you, and then you're not publishing your video. Huh? I would like to have a video interaction with you. Is that possible? Hey, please understand, I'm only just slightly, yeah, a lot of volumes. What will be the problem with a lot of volumes? I think we're not publishing. Who is the person who is interacting with me from Jntuk 50? Chhatrapati Shivaji College, Satara. How come Chhatrapati Shivaji College, Satara is on this? Hello. So why am I seeing this college, Satara College, on this? Are the other colleges a part of this? I don't know. No. Who is replying back to me on this chat? Okay, I don't know. Now I'm a bit confused. This 50, Jntuk 50, which is the PVP SIT college, I'm interacting with them. A lot of volumes. Why will that be a problem? Volumes. Who is interacting with me from Jntuk 50? Can you identify yourself? It is Rajesh sir. Okay. Are you a student, Rajesh? You're a teacher. Oh, faculty. Good. So, what do you mean by a lot of volumes? It will be good, right? When there are a lot of volumes, you will be able to put them, divide them on multiple nodes, run your map function. Whatever output is coming, you should be able to put them together into the reducer, right? That should be easier, no? Isn't it? So that's a better thing. More data is better. Only thing is, whatever computation you want to do on this data, you should be able to express it as a map job and a reduced job. If you're not able to do that, you will not be able to use this framework called the map reduce framework. Okay. MapReduce need to distribute the entire data on the cluster. That's the assumption, right? HDFS will distribute the computation on all the nodes, as many nodes as it is possible. But I think the cluster size is limited. That's the whole point, right? So, as you see the data, okay, large data, if the cluster size is limited, you have to go to a bigger cluster. For example, you want to process, Google wants to process the whole of the web data, running into petabytes. Obviously, they will buy a bigger cluster. So that should not be an issue. But once you have a big cluster, MapReduce will make it easy for them to run the jobs. Okay? Clear? Okay. Now I think I will go to Vijayanagaram campus because they have been asking a lot of questions. One of the very good colleges I found on this is Vijayanagaram campus. I'm so happy and pleased with whatever I gave immediately they have been able to do, and their response was tremendous. So I should congratulate Vijayanagaram campus. Okay, I think they have been doing extremely well as opposed to their University College campus college. Vijayanagaram campus seems to be doing extremely well. Okay, I should compliment them. Well, and also the kind of questions, the kind of things they have done during the lecture is extremely good, which is so nice. Okay, So let me go to Vijayanagaram campus for a minute and then discuss with them a little bit, and then come back on Saturday between 10 o'clock and 10 and 1 o'clock. Okay. Let me see if they are available for me. Yes. So Vijayanagaram campus, right? This is Vijayanagaram. So what are your names, ma? The two students. Can I get your names? The front bench. That red color, this thing, and then the black color. What are your names? Is the mic working? Your audio is muted, I think. Can you just tell me your name? Sita.
Devasri, sir.
Jayasri.
Yes, sir.
Okay, okay. And what about your friend?
Monica, sir.
Huh?
Monica, sir.
Monica, okay. See, I have a question for you. Have you done Lisp programming? Have you done Lisp programming?
No, sir.
Okay. Have you done C and C++ Java programming?
Yes, sir.
You have done C programming, Java programming, I guess, right? Is Java programs Turing complete?
Yes, sir.
Is Java program Turing complete? Is Java language Turing complete?
Yes,
How do
sir.
you define Turing completeness? How do you define Turing completeness? There was a question from there, from your campus. There was a question. Is MapReduce Turing complete? So I just want to find out. Who was asking this question and what is his understanding? It's a nice question. It's a very good question. So I want to find out. Who asked the question?
Sir, actually,
Somebody
Venkatesh,
who asked the question? Is it
sir, actually, Venkatesh sir asked the question, sir. Sir has went out, sir.
Oh, Sar is not there? Okay. Okay, so I want to ask this question. There was one answer here. Fibonacci series is difficult, something like that. Okay. Who gave that answer to me?
Sir,
Computation depending on previous computed values like Fibonacci series is difficult to express. Who gave that answer? Okay, Jayashree. Okay. Now, think of this. Why will that be difficult to express it in a MapReduce computation?
Maybe MapReduce functions అప్పుడు ఇన్పుట్ తీసుకుంటాయి కదా సార్ ప్రెసెంట్ ప్రీవియస్ వాల్యూ బుర్ర స్టోర్ అయి ఉండవు కదా సార్ నేను అలా అనుకున్నాను.
Okay. So I think you are coming to the very nice point. The nice point is if the maps require some communication with each other, okay, then you will have a problem. If there is any dependency in the computations of the map job, then you won't be able to express that as a MapReduce computation. Okay?
అండ్ అలాగే MapReduce ఇటరేషన్ అందరూ నాకు అంటే దాంట్లో లూప్ కానీ ఇటరేషన్స్ కానీ ఇవ్వలేమన్నట్టు కదా సార్ ఇప్పుడు.
Correct. That's one problem. The other problem is only speak in English. Don't speak in Telugu. Okay, I can also speak in Telugu, but I want you to speak only in English. Okay? Is the instruction for you English or Telugu? Instruction is English, right? Yeah, so that's okay. I'm trying to encourage you to actually speak. Okay, that's a very good point you brought out. If two maps have to communicate with each other, one map compute something and it needs to give that value to another map job, then it will be very difficult to express that. Right now you can't express that as a map reduced job. Okay? That is what exactly the answer that we are giving. One map computes something and it needs to give the value of one map to another map. You can't do that in the map reduced computation. Okay? Is that clear? Is that clear?
Yes, sir.
One map computes something and that is to be communicated to another map. The input of one map is required by the other map job for doing something, then it will be very difficult. That will be a problem in expressing it in a map reduced job. Okay? Right. I will stop here, but I expect you to actually work on the problem that I gave you. Okay? And Abhinay will share the Twitter data. You need to write a map reduced computation. What? Please mute your thing. It's reflecting back now. Okay? So we'll come back on. Yeah. Okay. Have you muted? Please mute your Vijayanagar campus. Please mute your mic. Yeah. Okay. So I'll come back on Saturday between 10 and 1. But then I expect the students to do their co-occurring word count example. What they need to do is the word count exam. Take any input to your word count problem. Okay. Then what you need to do is, given one word which occurs more than 50 times, I want you to find out all those other co-occurring words which also occur more than 50 times. Okay. So you have to run, as I was telling you, you have to run the map reduce. Output of one map reduce job has to be used for running the second map reduce job. I want to see how many of you will be able to do this assignment before I come back. There is a second assignment that Abhinay will give it to you for all those who are actually sharing their email ID. Okay. So take that assignment, which he will give you a link for taking the Twitter database and outputting all the hashtags. All the hashtags, how many times those hashtags have actually occurred in the text, in the tweets. Okay. These are the two examples that we want to give you. And Saturday between 10 and 1 is going to be the last class, since this is the last working thing. Okay. This lecture, you see, though I was actually sort of telling you, all people should give it. We in general enjoyed, but we want to see how many students really, went and then benefited by it. That's more important for us. That's why, for us to continue this exercise and try to do this a second or a third time, we need that information. How many people really got it and how many people are really able to work with us and benefit out of this. That's the reason why we want those numbers. How many students really attended? Have they been really able to sit down and then code? Did all the colleges get this Hadoop cluster, Postmule Hadoop cluster? Tomorrow will they be able to use that for doing some additional projects and assignments? That's what we are looking at. That's the reason why we want that information. In general, I found most of the colleges are present and they're doing an excellent job. That's no doubt about it. It's only for our sake of understanding how each one of you have got benefited by this thing, for us to see how we can improve or change or give more different other things for you. We want that information back. Okay, good. So we'll come back on Saturday between 10 and 1. You can check with Abhinay whether if you have any doubts.